guys, I'm really glad to see you at Waterstock. Hope you're having a good time here. And now let's talk about smart and tiny stores and how we can make front-end simpler by using them. My name is Nina. I'm an engineer at Evil Martians. We're not that evil, we're engaged in product development for both startups and large companies, and we're also actively developing open source. When I was a beginner front-end engineer, I was attracted initially by front-end because I could see the visualized result of my work relatively quickly. And there was time when 3 tools were enough. Developers were learning HTML, CSS, and JavaScript, and then we were able to build front-end parts of applications of any complexity. But the world of web development has changed quickly, and today 3 tools are not enough. Today we have these. A lot of package managers, preprocessors, build tools, and other libraries. And all of this started when we got frameworks. We believed that frameworks would give us convenience and increase our speed of development process. But what we eventually received? The modern web development world is becoming more and more complex every year. But the most crucial part of it is that people suffer. And first, we suffer. Developers suffer because we are the first ones who meet the bad consequences of our own developments. We are drowning in frameworks and different libraries and utilities for frameworks. And for what? Sometimes just for the illusion of convenience that frameworks promised us but then deceived. And we still need to do a lot of actions to build something simple. For example, when I start a new project, I need to set up environment. I need to set up test environment, add JS preprocessors, CSS preprocessors, linters, and so on. So frameworks didn't make our life much simpler. The second type of people who suffer from increasing complexity of web development world are users. And we know that if users suffer, everyone else will suffer later. But here is one important fact. The average web page size is growing every year. And if in 2012 the average web page size was about 800 kilobytes, then just 3 years ago it was about 2,300 kilobytes. That's a big growth. The more complex tools, the more code, the larger the web page size, and the slower load time. And a slow page load time is actually a huge problem for users. How long do you usually wait a site for a load until you give up and try to find information somewhere else? The statistics show that every second is important to not lose a user. Finally, from increasing complexity of web development world suffers business. And not only because of losses of users, also because developers burn out. Often we need to put the same amount of resources to achieve the same result. And if we add the need to maintain a no legacy code or fix code after wipe coding, sometimes we receive a result that business needs to wait even more time and spend more resources to receive the same result. And waste both time and money, and as you know, it may have very bad consequences for business. So let's sum up. From increasing complexity of web development world suffers everyone. Developers, users, business, and the situation doesn't become better, it's even getting worse sometimes. Maybe we need to make a step back and change something. Let's try to find inspiration and listen to some wise ideas from recognizable people from our community. For example, this one. Fold knowledge into data, so program logic can be stupid and robust. That's a quote from Eric Raymond, a well-known open source ideologist. And in his book, The Art of Programming for Unix, he presented a number of minimalistic approaches for modular software engineering. And this one was called rule of representation. Let's try to apply this idea to our problem. Currently, the modern web development world revolves around frameworks. When we work on a project and we need to add some new tool, we usually check if this tool is compatible with our framework. And many libraries are developed particularly for specific frameworks. And also, components in frameworks are now responsible not only for how we display information, how we show it, but also how we store and process data and how we implement some business logic sometimes. But the more work component does, the harder it is to test, to change, and to maintain it. All of this can be presented as sort of space model. But what if we made the same mistake that humanity made centuries ago? Because people used to think that all the objects in solar system revolves around the Earth and not the Sun. So maybe we made the same mistake and placed the wrong object in our center. We also can shift our focus and move from framework-centric model to data-centric model. So it will be closer to the idea of fold knowledge into data. So everything else would revolve around data and not framework. But what exactly do I mean by a concept of data? What is a well-known process in the web development world when we store some data? I'm talking about state management, which is a process of maintaining knowledge about application between multiple parts. And in this concept, we also have a concept of store specific places when we can save this data. So, to move from framework-centric model to data-centric model, we want to move logic outside of components to stores. So our components can be stupid and robust and be responsible only for how we show in information. Stores can be more smart and they can give the needed information to components. That will be closer to the idea of fold knowledge into data. Okay, we figured out something. Let's remember this idea and move forward. Bad programmers worry about the code. Good programmers worry about data structures and their relationships. That's a quote from Linus Torvalds, a lead developer of Linux kernel. And he emphasized the idea that before writing code, we should think more about architecture and data structures. So let's do this and think about data structures. Currently, both now and a lot of years ago, the most popular approach with state management is an approach with global single object, when we just store all the information about application. That's a workable approach, but it has some drawbacks. For example, all the components need to call the selector function on every state change. And also our chunk may contain data that is not currently used on a user's page. So let's try to optimize it a bit, make it faster, and using all the needed data. And here we can find inspiration in approach from reactive programming. And it's called observable pattern. It means we have some subscribers that can register themselves as observers. And then they will be automatically notified and can update this value when a value inside observable object changes. We can apply this concept to our concept with stores and components and make components subscribers. So they will be automatically notified when value inside store changes. But we also don't have a restriction that we need to have only one single and huge store. We can make a lot of atomic and smart stores. So our components will subscribe only to stores they need and receive only the data they need. But in the real world, cases can be much more difficult, usually. And in a lot of cases, some data depends on other data. How should we handle this case? The solution here is simple. We want to allow not only components subscribe to stores changes, but also stores subscribe to other stores changes. So when a value inside one store changes, all dependent store will be automatically notified about this change, and also components that use all of these stores. So we will just update everything through a chain of reactive computations. So now we have two ideas. First, we want to move logic to stores outside of components, so our components will be stupid and robust. And the second, our stores will be small and smart and give the needed data to components and other stores. Let's go further. The next quote is not from a developer, but from a writer and aviator, Antoine de Saint-Exupéry. He said, perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. And that's true and can be easily applied to development world. Have you ever seen such a web interface where there were so many features, so you just got confused in them and you couldn't find the needed ones? That's a good example how redundancy can ruin even a very good product. When I was a beginner developer and I learned about state management for the first time, actually I was trying to do something really simple, like receive data from a server, data about my user, and display it in multiple components of my application. And when I started Googling what state management is, I found such a scheme with a lot of different entities like reducers, selectors, effects, and with many complex relationships between them. And of course, it's all made to handle difficult cases. But in my case, in a very simple case, all I wanted to do is just two simple things. Just set a value about my user in a store and then get this value in my components. The harder the logic, the harder the mental overload, and larger the probability that we just get confused in entities and relationships. But by the concept of simplicity, I don't mean oversimplification. And as Albert Einstein once said, everything should be made as simple as possible, but no simpler. Because we still need to take into account different complex cases. And there can be a lot of developer challenges when we want to change our state, depends on the challenge that we have. For example, we may want to automatically translate the content of our application. Or we may want to resolve conflicts between different devices. Or implement SPA navigation and change our state based on this. And this list can be expanded for eternity. So in an ideal case, we want to achieve some balance between hard cases and easy cases. Because for easy cases, we don't want a lot of entities and we don't want boilerplate. No one likes boilerplate. But for hard cases, we want to reduce mental overload. So we should find some balance. We have figured out something. Let's summarize the ideas. First one, we want to move logic outside of components to stores. So our components will just notify it from stores when they want to. Also, we want to allow stores subscribe to other store changes and make our store small and smart. Third, we want to provide minimalism and simplicity. So in perfect scenario, I just need 3 one-line operations to create a store, to get value from it, and to set some new value. And of course, ideally, we want some useful and simple tool to consider different developer challenges. We may want to automatically fetch data from our server on some state change, or we may want to automatically translate the content, or different and other things. And me and other evil Martians were thinking a lot what tool would suit all our requirements and fit all our needs. And we didn't figure out, so we created our own tool. It's called Nano Stores. Nano because its size is less than 1,000 bytes. And it's built around all the concepts I just told you about. But enough just talking. Let me show you how it works on a real case scenario. We want to build a simple online shop. It will consist of 2 pages. First is catalog. You can see a header, it's Nano Shop Catalog, and you can see a list of Nano products. And you can also search in this list by the name in this search field. And you can also go to a cart and browse items in cart there. Here is also a header Nano Shop Cart, and we can come back to catalog. So let's start. First, we create a file that's named state.ts, and we import a method atom from Nano Stores library. That Nano Stores library is framework agnostic. You can use it in any framework or in plain.js, whatever. So here we create our product store. We invoke the atom function, and we pass as an argument the initial array of our products. That's just for a simple case for now. And we can also specify a value type as a type parameter, as we use TypeScript. Then we make this store exportable, and we use it inside our new catalog.tsx component file. In this component, we subscribe to store changes. In this demo, I use React, but framework doesn't play any significant role here. So this hook use store is needed that if you use framework, you can allow to subscribe in the component to the store changes and automatically render a component when the value inside store changes. We supported this use store hook for all modern frameworks: React, Angular, Vue, Svelte, Solid, etc. So here we just subscribe to the store and return the array of cards. And that's all for now. So these are a few one-line operations. To create a store, then we got value in the store, and here we displayed it. Let's support filtering using search input. So when a user types something in this search input, the products in our list will be automatically filtered. Here we will need another atom store. So as search string is in the beginning it's empty, we just pass empty string for this atom array in the beginning. Then exactly the same, we create a search bar component and subscribe to the search input store changes. Here we return HTML input, and in these attributes we bind value to the value of our store, and also on every change event we will invoke a function that sets this value to the store that we have. So the values between this search input and our store are always synchronized. Now we want to filter our catalog based on the value inside this atom store. And here we need a new function that is called computed. We need to import it from Nano Stores library. We invoke it, and it accepts two parameters. First is array of stores that our store will depend on. And the second argument is a callback function, which is invoked every time when value in either of the stores changes. So here, when a value inside search inputs changes, we just filter the list of our products based on their name. Using computed store in components is exactly the same as atom store. Here we change the store that we use in catalog.tsx, and we display the filtered list of products. So now when a user types something in a search field, we will see the updated list. But in real-world situations, it's usually more complex, and we don't store catalog items on front-end side. We usually fetch it from server. So let's support this. And for this case, in our Nano Stores world, we have a separate tool that is called Nano Stores Query. It's a tiny data fetcher for Nano Stores, which allows to automatically fetch data from server and save it inside Nano Store. Let's see how it works. First, we need to define fetcher context. That will allow us to ensure that all the fetcher stores that we use share the same behavior. It will also make it simpler to use it in tests or stories. Here we import a new function nanoQuery, which receives the default fetcher implementation. And our fetcher is transport agnostic. You may want to use REST API or anything that returns a plain promise. Here I just use plain fetch. When we receive data from a server, we read it and parse it. Then we create a fetcher store using the context that we just have created. It's called fetched products. And this fetcher store is reactively connected with all stores or keys that we list in the first argument. In our case, our store doesn't depend on any other store, so we can just pass a string here. Using fetcher store is exactly the same as atom stores or computed stores, with just a slight difference that now we have not only data, but also a loading flag and error flag. So when loading flag is true, we can show a spinner in our component, or if it's error, it means that loading finished unsuccessfully and we can show error. In other case, we just map the content of in our data. Here is it. So when the data is pulled from server, we show spinner. Then when loading is finished, we show the list. Our fetcher store has a wide range of customization settings. because we may want to refetch data on window refocus or network connection restore. Under the hood, our fetcher uses a built-in cache. So when we revalidate the cache, the fresh data is pulled up. And we also may want to revalidate cache on some interval. We also can set it all when we create fetcher context. One small detail that we want to add is shown in the header. We want to add two routes for catalog and cards itself and display it in our headers. And here we can use another tool from Nano Stores ecosystem, which is called Nano Stores router. It's a tiny URL router for Nano Stores, which allows us to create router object and treat it as a plain store. So here we create router store using the method from Nano Stores router, and this method receives an argument that's an object of correspondence of routers and their URL patterns. They can be written as strings or as regular expressions. Now we use router store. We create a new component router, which we place inside the main component of our application. Here we subscribe to router changes, and we also use switch case structure to render catalog page if our current router is catalog or card page. Our card page is built exactly the same as catalog with a small difference that it's connected with another store, not for catalogs, but for the card. Now we subscribe to storage changes. And we also may want to subscribe to storage changes not in a component, but just in a plain file. Here in router.ts we create a new store that is called header name, and we subscribe to router's change. It's also a valid syntax. So when a value inside root change, we set a new value for header, and we can also set the same value for HTML document title. And exactly the same as we did it before, we use the current value of header name in our header component. And that's it. When we see the catalog page, we see the header NanoShop catalog, or if it's card, we see the card. One last thing. That's the whole code of NanoStore Atom store. And that's an open source tool. I believe that when you can fastly read the source code of a tool you use, it's much better. So no more obscure labyrinth or black boxes. We believe that moving to easy-to-understand processes is important and necessary. So when next time you understand that you want to use a state manager in your project, just try to find a minimalistic approach. And just in case, Nano Stores will be ready to help you with it. Thank you for your attention.